Volcanic supereruptions. These are defined as singular explosive eruptions of unimaginably large size which eject at least 1,000 cubic kilometers worth of tephra, whether that be through ash, pyroclastic flows, or pumice. The most famous volcano that produced a supereruption is the Yellowstone caldera located in Wyoming, whose eruption 631,300 years ago ejected exactly 1,000 cubic kilometers of tephra. Yet, the United States and New Zealand are not the only places in the world which have produced supereruptions, as if we head to an interesting strip of land just northeast of the city of Melbourne in Australia, we can find the remnants of another such supereruption. This is the story of the long-extinct Cerberean Caldera, which in a single massive eruption dated to 374 million years ago emplaced up to 1.2 kilometers thick of volcanic rock in only 2 weeks. Today, some of these ancient volcanic rocks of a catastrophic origin are located within Lake Eildon National Park. Now, I keep using the word caldera in reference to this ancient volcano. What exactly do I mean by this? A caldera is a volcanic depression in the ground, much like a supermassive sinkhole that forms when incredibly large volumes of volcanic material are erupted, causing overlying ground to collapse downwards where the drained portion of the magma chamber was. Thus, the Cerberean Caldera, measuring 34 kilometers long and 18 kilometers wide, represents one such area of ancient subsidence over an ancient drained magma chamber. So, why exactly is it then that this area is still not a depression in the ground, but instead a raised feature compared to nearby geologic outcrops? Simple, preferential erosion. The rock units in place during this ancient caldera-forming eruption were highly welded and thus hard rhyodacite ignimbrite. This rock was far harder and more resistant to erosion than the numerous contemporary sedimentary rocks that surrounded it. Thus, over hundreds of millions of years, this caprock has protected the underlying rock units where it is thickest, inverting the topography of what was once a massive depression in the ground. So, how did this ancient volcano form? Approximately 374 million years ago, what is now Australia was the easternmost landmass of the supercontinent known as Gondwana. This landmass was connected to sections of South America, Africa, the Middle East, Antarctica, and India. At the time, a large volcanic arc stretched across the eastern edge of the country, which was located partially in Victoria. This arc contained numerous stratovolcanoes, but in localized areas where substantially increased partial melting occurred, unusually large volumes of magma were able to rise into the crust. This magma reservoir, as time progressed, became more and more silica-rich as both fractional crystallization and some leaching of silica-rich rock in the existing crust happened. While it is tough to know exactly what this magma chamber did before the supereruption, here is some limited speculation. It is quite likely that lava dome complex volcanoes formed on the surface with sizable but spaced eruptions across the preceding several 100,000 years. Some kilometer-wide explosion craters could have also formed. Regardless, extreme amounts of pressure and volatiles were still building in the underlying Late Devonian Period magma chamber. Eventually, this building pressure passed a tipping point, resulting in large volumes of dacite and rhyolitic magma being sent upwards. Then, a massive explosion on the surface occurred, and soon several vents likely oriented in a relatively straight line were emitting millions of cubic meters of rock per second that were largely pulverized into finely grained ash. Soon, the eruption column reached an altitude of 50 kilometers or 164,000 feet. As this eruption plume expanded outwards, it soon turned the day seemingly to night due to both the plume and the substantial amount of falling ash which both blocked sunlight. While this was occurring, heavier material in the plume fell back to the ground, creating superheated pyroclastic flows that expanded outwards in all directions at speeds exceeding 200 kilometers per hour. These would incinerate everything they touched, even reaching beyond 100 kilometers away in some spots. As dozens of meters thick of ash fell across much of Victoria, the eruption continued. Then, due to the large volume of material erupted, a wide section of ground collapsed downwards, forming a large caldera. At its center, the eruption deposited a 1,290 meter or 4,232 foot thick layer of volcanic rock. In total, 1,100 cubic kilometers of volcanic rock had been ejected in a true supereruption. Although no subsequent eruptions occurred from this volcano, volcanic activity continued in Victoria during the remainder of the Devonian period. As a final note, I would like to thank my new YouTube channel member Jim Lockhart for supporting my work.